So many of our investment, we commit our resources today, and we expect to get returns at future date. And we know that the future is not certain. You cannot know what is going to happen in the future. So meaning that in the investment decisions, or when we are making investment decisions, we must incorporate risks and uncertainties in our decision. So we have got different methods of incorporating risks in the investment decisions. You can use the probability, we can use the certainty equivalent factor, we can use sensitivity analysis, we can use simulations. Those are different methods which you can use to incorporate risks in our investment appraisal. So if I can see even the keyboard.
You say probability, sensitivity analysis, insemination, and
certainty equivalent factor. And then my internet is still saying it's not stable. Incorporate risks in investment appraisal. So number one, we have the probability. What probability? Number two, we have certainty equivalent factor. Equivalent factors. Three, you can use sensitivity analysis.
Oui. Yes. Yes, sir.
Please mute. And the number four, can do simulation. So these are different methods that we can use when we are incorporating the risks into our investment. So if we look at the first one, the probability. Now, in the probability, what you need is to determine the expected value. Then once you have the expected value, then you can be able to determine whether the project is okay or not okay. But what you do is to get the expected value. And how do you get the expected value? To get the expected value, you just get the cash flows, then times the respective probability, get the expected value. So this involves determining the expected value of the cash flows. So, and how to get the expected value? Our expected value will be equal to maybe the cash flows in situation one times the probability in that situation. Cash flow in one, maybe put one, times the probability of one, plus. You can't hear me, Freddy. I don't know. What other members? Are you hearing me well?
We are hearing you, sir.
We are hearing you.
Hearing.
So cash flows in the period 2 times the probability in the period 2 plus cash flows in the period 3 or period up to cash flows in the period n times the probability in the period n. Then what we are going to get is the expected value. And once you have the expected value, then you can be able to compute your NPV from this. So you just get your cash flows, then times the probability to determine the expected value. So maybe a simple case, can you put a simple case? Company X is evaluating a project that requires 1 million francs. Please mute Mutoni. The project can generate the following cash flows with respective probability. So maybe if the economy is good, these are economic conditions. Economic conditions. It can be good or very good. They can be very good. They can be good. They can be poor. And they can be very poor. Now, if the economic conditions are good, the probability for economic condition to be good maybe 0.45. That's the probability, 0.45. And the economic condition to be good, maybe 0.25. This is 0.2, and this is 0.1. So those are the respective probability. And the cash flows that we have, our cash flows, I'm going to remove 3 zeros. If the conditions are good, are very good, the cash flows will be 40 million. I've removed the 3 zeros. If the cash flows, if the economic conditions are good, the cash flows will be maybe 20 million. If the economic conditions are poor, you will have 10 million. If the economic conditions are very poor, then you have a minus 4 million. Minus 4 million. Those are the cash flows. So now the required will be determine the expected, evaluate the project, whether the project should be taken. Now, as we said, if you are to get our expected value, the expected value, we are getting the probability times your expected cash flows or the cash flows. Get the expected value. Probability times the expected cash flow. Probability times the expected cash flow. And here, get the
What
cash
is the
flow.
question, lecturer?
Okay, I didn't pose the question. So required, advise the management on whether to undertake the project. That is the required, advise the management on whether to undertake the project. Maybe I can now remove this and do them down, because this is where the question is. So if I can copy the same here, so we can have our expected value. So I will have this times the expected cash flow, which is that. I will have the probability times the expected cash flow. Get the probability times your expected cash flow. And even here, get the probability times the expected cash flow. So what is the total expected value? So my total expected value, I'm just going to add this to get the total. What is the... Don't forget the figures. We have eliminated the 3 zeros. So it means this is the project, and the project requires. So if you look at our initial investment, if maybe we are getting the expected, our expected net present value, NPV, will be equal to our expected present value. We are showing these cash flows are discounted minus the initial investment. Minus the initial investment. So our expected NPV will be equal to 24,600 minus 50. And we get this minus 50. So automatically you are rejecting this project. It is loss making after incorporating the risk. The project becomes loss making. So that is how you are going to incorporate the probability. What you need. Please always mute your microphone when you are. So that is how you are going to determine the expected present value. Just get your cash flow, multiply by the probability. Now, the challenge on this is when you have more than 1 year. I think you have looked at that. When you are evaluating a project, for example,
more than 2 years. 1 year.
Huh? Yeah, if you have 1 year.
1 year.
Yes, if you have more than 1 year, that's where we can have a challenge. Because this one, we're expecting it is 1 year. Suppose it is more than 1 year. That's where you can have a challenge. I think you have seen that in your performance management, where you have to use a decision tree, or you have to use a payoff table. So if you have more than 1 year, suppose you are having more than 1 year. This is 1 year. But suppose you are evaluating a project which is more than 1 year. Screen is always that. Please, I'm going to mute you.
uzagira 55 kw'ijana
Is disturbing us.
utazayabona azasibira. Biravuze ngo
Colleague, uwo muntu se ntabwo mumurebera
Ni François. Ni François.
Kanze muhamagare.
I've
François,
muted
please.
him. I've already muted him. Please, if you don't, I'm going to mute you all if it is that, because even the recording we are making, we are just you. It's not, you won't get anything in that record.
Can you make anyone a co-host to be helping you in that?
In what?
In muting people.
Okay, maybe I can do that, but I can mute you all. Or maybe I can select one to be a co-host.
Sure.
Yeah, it's better to select someone.
Scovia has a co-host.
So we are saying this is expected value if you are evaluating only 1 year. Suppose you're evaluating a project of 2 years or 3 years. How are you going to go about it? So in that case, you can either use a decision tree, which I think you have looked at the management performance, or you can use a payoff to be able to evaluate. So evaluating, incorporating or evaluating a project of 2 years or 3 years. Of more than 1 year. If you're evaluating a project which is more than 1 year, how are you going to make it? So there are 2 ways. There are 2 ways used to evaluate the project. Which is more than 1 year. Number 1 is what you know, using a decision tree. You can have a decision tree, and the number 2, it can be a payoff table. You can have a decision tree, or you can use a payoff table. Now, if it is a decision tree, you just do a decision tree and then determine the expected value using a decision tree. However, the only limitation to this is that you cannot exceed 3 years. The maximum for decision tree for payoff table is 3 years. You cannot evaluate more than it cannot accept when you are using this probability. So I want us to look at maybe a simple example that is going to help us to understand these 2 methods. Decision tree, of course, you are doing a decision tree, or you can have what called a payoff table. Now, if you can look at an example to help us understand this. Steel company X is evaluating a project that requires investment in assets of 100 million. from the market survey, the economic conditions can be good or bad. The probability. Please, I'm already recording. Don't ask again to record. The probability of the economic conditions Yes, BBG.
Yes, sir. I have been experiencing electricity problems, and I have a question on the expected NPV. There are things that you explained when I'm not there. I don't know.
But we are
if-
going to we are
Sorry?
going to repeat the same thing here.
Hmm?
We are going to repeat the same thing. But what you do, what you do when you are computing, of course, we are in the first part, we assume that the cash flows are discounted. That was the assumption. You get your cash flows or discounted cash flows times the probability to get the expected present value. Then once you get the total expected present value, less the initial investment to get the expected net present value. That's what we talked about, but we are going to repeat the same thing in our second example.
Okay, okay, sir.
So these are the economic conditions. Economic conditions. You said the economic condition can be good, or we can put the conditions such that we don't, the conditions, they can be good, or it can be bad. And this is the probability. This is 0.6, and this is 0.4. This is in the first year. Now, in the second year, I'm not. In the second year, if the economic conditions I have not put the cash flows. These are cash flows. Oh, the question I have not. It can be 85, 86. It can be 50. Then in the second year, if the economic conditions are good, I think I've written in. This is our second year. If the economic conditions are good, the probability here can be 0.5, 0.3, and 0.2. The cash flows you can have 40, can have 40, maybe 48, and it can be 30. If the economic conditions are bad, you can have 0.4, 0.35, 0.25. These are the probability. Then the cash flow, you can have 35, can have 30, they can have 40, say. I don't know if because the question is fragmented, I didn't maybe write it well. Be quiet. Advise the management on whether accept the project or not. If
Screw up.
the cost, yes, if the cost of capital is 10%, let's assume that I scroll up to where?
Up there.
Where?
Okay, it's okay. No.
Yeah.
Scroll down. I think there is a... Okay.
Missing information?
No. Let's just copy.
Well, this message of the second year, why don't you put it between the first and the second?
I wanted it, but I wanted it to put it down here. That we didn't take the but it would have been good to put it down. Can you move on? Because
No, wait.
hey, the power is back. I even didn't know. The power.
Reka aho naba nashize agatambaro kanjye aho ngaho yaba ariho hejuru y'iyo varisi.
I think we can move on, huh?
Up there,
Since
up there.
Since I'm going to share I'm going to share the thing.
It is very difficult to copy
Ah.
after. Mm.
Excuse me, sir. I'm not understanding. I'm not understanding how the question is because in the first year we have only two probabilities of bad and good, and then when
Yes.
you come to the second year, good has three probabilities.
Which is very
And
common.
but-
It means in the second year, there are chances that the economy maybe can it be good, can it be average, can it be poor.
And how about this, the down one, if the economic condition is bad? It has also three probabilities.
Yeah, it is.
You
If
say
the
there is
economy,
up where there is 5,
Yeah.
3, and
Yes.
0.5, 0.3, and 0.2. And then down bad 0.4, 0.3, 0.2. So
Okay.
there are three probabilities when it is good and three
Let's
probabilities.
put it in put it in real terms. Our first probability, the economy is good. If the economy is good in the first year, the chances of getting the cash flows are 3. There is a probability that the cash flow can be 40 if the economy is good. There is a probability that the cash flow can be 48. There's a probability that the cash flow can be 30 if the economy was good. Now, if the economy was bad, still you have 3 chances.
That is in the second year.
In the second year.
What about
Maybe
in the first year?
In the first year, you only have two options.
Okay.
Two chances.
So maybe we can present it. We are going to use a decision tree. I think you are expert there. If you use a decision, first, we first get the present value of the cash flows. What is the present value of cash flows in the first year? That's the first step. The PV of cash flows in the first year. So remember our cash flows in the first year, it is either 85. What are the cash flows in the first year? It is either 86 or 40, 50, sorry. It is either 86 or 40. And our discounting factor, which is 10%. This will be what? I think you know this one, 0.909, I think like that.
No, it is not 4, it is 50.
Sorry. Okay, this is 50. So what will be the present value in the first year? Our PV. This times with this. These are the cash flows in the first year. If the economy is where you have a bad and a good. Now, what about the second year? Second year.
On the first year, discounting factor is 10%.
10%. That's the discounting factor. So what are the cash flows in the second year? Our cash flows, the PV factor, our discounting factor, and our PV. So we have got different cash flows in the second year. I'm just going to copy them. We have this. If the economy is good. Yes, please.
Yeah, for the first working, we've assumed that the given cash flows are discounted.
Yeah, but here.
But for this scenario, why don't we also assume the given cash
because
flows?
we are given a cost of capital, means the cash flows are not discounted. We have a cost of capital. To me, we need to discount our cash flows.
Okay.
Yes. I'm also copying this. Maybe I can make a color change. These are economy is bad. What's the discounting factor in the second year? It will be 1 plus 0.1 power minus 2. And our PV is going to be this times this. Remember here we are separating. This is where economy is bad. Now, can we now draw our I think it will fit here. I'm not going to. We have two choices or two alternatives. Economy can be good, or the economy can be bad. These are the alternatives we have. And if the economy is bad here, we said the probability here is 0.6. And here it is 0.4. Ooh. We didn't even accept going there. Okay, that is fine. Those are the probability. Now, if the economy is bad, it's good in the first year, you still have 3 alternatives or 3 choices. You can have this. You can have this. You can have this. And even here, it's the same. It can be here. It can be here. It can be like that. The challenge is now writing there. So now, what is our cash flows here? If the economy is the cash flows, here we got what? It even accept. Did you copy that? 78, 174. 78, 174. It even be there. Okay, maybe we can take that. And here, it is 45, 450. 45, 450. Okay. Now, the probability here, if we can put it here, we have a 0.5, a 0.5, and what's the cash flows? 33, 0.50. Maybe I can put it there. The cash flow is 33, 0.58. And here, the probability is, oh, this one, take 0.3 and 0.2. We have a 0.3, and the cash flow is 39. $669. Please remember my cash flows are not negative, but just to separate it from the probability. But my cash flows are not negative. So I hope it will not confuse you.
Yes, no, it is clear.
0.2, that's the probability. The cash flow is 24, 793. I think that is the first one. If I put them there. Now, the second one, what are the probabilities? The probabilities are 0.4, 0.35, 0.25. So here, it can be 0.4, and the cash flow will be 28, 926. This is going to be this one is 0.35. 0.35. The cash flows are 24. $793. And the last one, it is 0.25. And the cash flows is 33, 0.58. I think I've put all the cash flows into my loops in the decision. So what comes next is to determine the expected value. So what is the expected value if the economy is good? That's the first thing. Expected value. Expected value if the economy is good. So what we are going to do, remember we move from right to the left. we are going to get I can put them into it is easy to copy them like that. I copy these ones. If the economy is good, these are the probabilities. I don't know if you will follow it, but I wanted to see if I can summarize them here down. These are the probability and our cash flow. I copy these ones, which we have them there on our tree. Then expected value, as we said, you multiply this times this. So it is this times this. And it will be this times this. So the total here will be that's the total. Now it means in this case, it means I'm getting a total up to this point here. I don't know if you follow. This 33,388 is the total of this loop up to here. This one, which is 33.
You mean the total for bad economy condition?
No, good in the total of the second year.
That means the good economic condition and the bad good condition.
No. I'm still where the economy is good in the second year.
That is 50% probability.
Yeah. You see this total? This is a total if the economy was good. The total expected cash flows if the economy was good in the second year. So what will be the total expected value if the economy is good? Will be the cash flows in the second year? Isn't it? Times the cash times the probability of the first year times the second, because we are looking at this is like a conditional probability.
What do you mean?
There? Huh?
We are lost.
Because we are looking at the probability. That's what we are looking at. Of having a cash flows in the second year, which is good, given a good cash flows in the first year. That's a conditional probability. So what we are having, this is the cash flows in the second year. Because what we have done here is to get this times this probability, plus this times this probability, plus this times this probability. What we are getting, you're getting a total here of the second year cash flows.
It is confusing.
Huh?
Confusing.
So,
the second year, come on.
And let me write it here down. Maybe it can make sense. What we are getting is this 0.5 times 33. That's how we calculate 0.58. Seriously? Plus 39,669 times 0.3. Seriously? That's what I've done.
Yes.
Plus 0.2 times 24, 793. And what we have got here is this one. Only that here, 33, 388.
Okay.
33, 388. That's what we have got. It means these are the expected cash flows in the second year. Seriously?
Yes.
So what will be the expected cash flows if the economy is good? Expected cash flows if the economy is good.
Is it good again or it is bad?
No, yes, because we have not yet completed. That only that is the second year. You get the expected cash flows, which is 338 times 0.6. Plus.
Okay, go on.
Isn't it?
Keep going.
78, 174 times 0.6. That will be the expected cash flows if the economy is good.
But for which period? That is the total expected
First,
cash
the
flow.
total first year and the second year. Yes.
Of the 2 years.
Of the 2 years, if the economy is good.
Okay.
So what do you get? What do you get?
$66, sir.
Yeah?
It is 66, sir.
Yes. Like that?
907.
Yes, sir.
Okay.
Like that. That's 7.
Okay. 66, 937. So that is the expected cash flows in this when the economy is good. What you could expect. Now, what will be the expected cash flows if the economy is bad? Remember, we are still coming from right to the left. So it's going to be, I think now I should write, it will be our expected value. In the second, it will be 0.4.
The past paper Baba more than 1 year.
Yeah,
I have not seen it. They always ask 1 year, I think. 226. But in I think in Nani they ask it in the performance. 0.35 times 24, 793.
What is the total for the 2 years? Expected the cash flow.
When the economy is good,
Yeah.
it is 66,937.
66,937.
Yeah. .25 times 33, 0.58. Now I'm waiting for your answer now here.
But I'm wondering whether we cannot do it without drawing that decision tree.
Which other method? The other method is the payoff table.
No, you just use this expected value.
These are probabilities. There's no way you can use it in either way. You are either using a decision tree or you are using a payoff table. If you don't do that, you're going to get out. You don't have any choice, sir. Yeah, it's either decision tree or a payoff table. Only that your calculators today have become slow. Maybe I can copy this. I can copy this. Hey, Mliwa, what you are guys?
No kwa Scovia wagaruse.
Yego, wagarutse nanjye.
Kuba mwegeranye na perezida.
Yego. Natwe wagiye mbere, mwebwe wagiye nyuma, ubwo mwihangane. Yewe na Dr. ntitwabanje kugenda.
So if you multiply here, maybe we can only look at the decision tree. We don't go for payoff. And then we can look at other parts. So this is it. This is 28. That's the second year if the economy is bad. These are the cash flows. So it means this is the value up to this point of the, if you add these 3 years, this will be the, these 3 choices, this will be the expected value. So now what is our total expected value will be in the second year. It will be 28, 512 times 0.4 plus the cash flows in the second year was, in the, if economy is bad, 45, 450. $45, 450 times 0.4. Then what do you get again? The problem now today. What do you get here?
Go back up 45.
450, I think. This one.
Okay.
What are you getting?
29.
Lecture twabaye rose kabisa.
Our velocity. Says Chivilkwangire Srekanzende 29,
585.
585. Now,
Yes, that is it.
so if you look at this, I don't know, maybe because I separated from it. What is the total expected value if the economy is good? Will be the cash flows in the first year plus the cash flows in the second year, given this probability of 0.6. So we are getting, whenever you're working with the decision tree, you move from right to the left. I think that's the rule in the decision tree, from right to the left. So get these cash flows, then plus this. Then you get the cash flows. Then you get this, the total here, plus this. Then you get the cash flows if the economy is bad. So it means here, my total expected value, the total expected value will be this, will be 66. Yes.
I'm very confused now. Down here, where you put again expected value. This is for second
Where?
year or
Now this one, because for me, I wanted it to
down
here.
Oh yeah, round anga orogeze expected value.
Ano.
Yes. Now,
Sit.
that is the for the second year.
When the economy is bad.
It's bad.
Because we have two probability, two choice decisions, I think. Economy can be bad, economy can be good.
Ako gatebo.
Kae. Niko kamu this.
No, down.
Reka ngufashe mu Kinyarwanda babyumve.
Ako kari munsi.
Dusubiye kuri probability tree, ifite ibice bibiri. Nyine niho uri buhere, nibwo uri bumenye table yo hasi. Ifite ibice bibiri, ifite first year and second year. Hano hari 0.6 na 0.4 ni first year. Ziriya zo hirya ni second year. Noneho ibyo doctor yakoze hano hasi yashakaga gucalculating ibi byo muri second year. Ibi bya 0.5 na 0.3 na 0.2. Arabicalculatinga niho yabonye ya toto ya 33. Hanyuma iyo toto ya 33 amaze kuyibona araza yikuba ni ya 0.6 n'ibyayo nibyo byamuhaye. Nuvuga ngo aka gatebo karimo karasobanura iyi ntuza y'umwaka wa kabiri.
Yes.
Agatebo yakoze karako gusobanura ibya 0.5, 0.3, 0.2. Hanyuma kamara kubikuba niko kaje kabona ya 332 izi gatatu nyinshi. Umaze gukuba umwaka wa kabiri wonyine. Nukuvuga ngo ukubye izi probability za 0.5, 0.3, 0.2 ukazikuba na ya amount yazo ari hano. Nibwo uzi ukabona ibihumbi 30.
Ukabona cash flows.
Yego. Ukabona ibihumbi 33,338. Noneho wamara kubibona akaba ari byuzu ugakuba nibi bya first year. Aha hari 0.6. Ubwo uracyari kuri good gusa.
Yes, iyo turabibona manuka hasi ngiye nayo nabaye confused.
Hasi naho ubwo ngubwo iki yakoraga yari gukora good yonyine. Aka gatebo ko haruguru karasobanura good yonyine. Good ku mwaka wa mbere no ku mwaka wa kabiri bikaza bikaduha ibihumbi 66. Nuvuga ngo agatebo kashushanyaga ibya second year yamara kubona iyi 33 akaba ari bya kuba na 0.6 kugira ngo abone good yose. Noneho expected value
hasi no kuvuga ngo afite umurongo yabanje gukarikira expected value arangije akora breakdown yayo.
Yego.
I can see it.
So now tugiye gufata total. If the economy is bad and the economy is good, total expected value. Mu myaka yose, when the economy is good or economy is bad. Turafata? Our total expected value. Expected value will be area twabonye when economy is good 36, 9, 37 plus the value when the economy is bad, which is 29, 585. What you get is the total expected value. Which gives us how much?
$96,522.
96.
522.
Now, remember our initial investment is it? The project require how much?
100, I think.
Initial investment
Suppose
is
the
Because
economy
100 million.
is 100 million. So what is the expected NPV?
34.
Expected NPV will be
34.
96. We said 96.
34.
Okuyem
100.
like this.
warasaka gikora cyose kumenya aho byavuye ni 96,522 minus no 100 minus 96 yeah?
96, 522 minus 100. That's where you get to the 34 or 33.
34.78.
34 Mose. 34, Bonanga 33. You get what?
3478.
I think that's how we calculate. So I don't know if you have a question on how to use this. So which is minus, isn't it?
Yes, minus, yes.
Yes.
So we
Yes,
are,
sir.
we are rejecting. If I take you again, if I can ask you from this table, from the decision tree, if I can ask what is the probability? I think this is in the probability that any PV will be positive. If you go back to the decision tree, what is the probability of having a positive NPV? If you come here, what is the probability of having a positive NPV? So if you are to get the probability of having a positive NPV, look at this. Look at this, 78 and 33. It is positive. Seriously. Our initial investment is 100. Our IO is 100, if I can put it like this. Is that it?
Yes, yes.
So 78 and 33. It is more than 100. See, no?
So we sum, we make a summation.
Yeah, this plus this, it is more than 100.
Yes.
Yes.
So it means that is positive.
Yes.
Isn't it?
Yes.
So it
Yes.
means 0.6 times 0.5
5.
gives you a positive. Seriously?
Yeah. Yes.
Yeah.
Nibyo pe.
What about this and this? Still positive.
Still positive.
So meaning 0.6
6
times
plus
0.3.
3.
Nazo zikuwa positive. Seriously?
Yes.
Yes.
What about this and this?
Zo ntabwo zitanga positive.
So
Zayitanga.
plus
It is positive.
0.6 times 0.2.
2.
2.
Only positive.
Nayo ni positive. Omanuse hano? This and this?
Negative.
Yeah, negative.
Negative. This and this?
Negative.
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 This and this?
Negative.
Negative.
So what do you get here?
When
0.
Keretse tubanje kuzikuba tukareba.
None se Kacura ntazo mufite se?
Kwiga nta muriro ntabwo byoroshye.
Mubuze?
Hari abawubonye.
None si ibyo muvuze bitanga negative ni ibi. Negative ni ibi.
Aravuga ngo
Kuri bad.
Wowe umenya uri kwiga kuko atadoha kabisa.
Mubonye angahe?
0.6.
Urabona
Mbere siko
0.6?
ngo bimeze bite?
0.6 nagira ngo aravuga ngo probability y'ibihumbi 78 uteranyijeho 33.
Ubona urebye hariya ushaka probability yo kubona positive NPV. Seriously?
Yego.
What is the probability of having a positive NPV? Ufashe cash flow z'umwaka wa mbere.
Yego.
Which is 78.
Yego.
Uteranyijeho cash flow z'umwaka wa kabiri where the probability is 0.5. What you get? Seriously?
Yego.
What you get is more than 100. It means 0.6 times 0.5, they give you a positive NPV.
Yego.
Seriously?
Nibyo.
None oyongeye gufata umwaka wa mbere. Uteranyizeho cash flow z'umwaka wa kabiri where the probability is 0.3. It also gives you a positive. Seriously?
Nibyo.
Even here, it means the probability of having a positive, cash flows, all the cash flows where the economy is good, they give you a positive. The probability of having a positive will be 0.6 times 0.5, which is 0.3, I think.
Yeah.
Uteranyijeho 0.6 plus 0.3, which is 0.118 plus 0.12, which is going to be 0.6. So the probability of having a positive NPV is 0.6. And the probability of having a negative will be 0.4. Is it risky or not risky?
It is not risk.
Not risky. Although we are having a negative.
Because the bad one is the lowest.
Although we have a negative, but it's not a risky project. So I don't know if you have you have got what we were talking about in this.
No, it is equal to 6 actually. At the end, it is equal to 6.
Yes.
And
And the bad
So that is
condition is 4. So what does it mean?
Is it equal to 6 or 60?
No, 6.
60%.
60%, of course.
So that is how we, because there is high chances that your probability is going to be positive. That's what it means. High chances, although we have a negative, but you have a high chance that the probability will turn out to be positive. The NPV return to be positive.
And we end up rejecting the project.
You are rejecting, but you can based on that probability, you can see whether to take a chances or you don't take a chances.
Okay. What if we decide to take the project because the highest probability is positive?
Yeah, that is still okay, but then you have to explain to the manager if things refuses.
Okay.
So that is how to use a decision tree. I think it is the easiest than the payoff table. Yes.
That you mean that after finding the negative NPV, you can reason by saying that it is not risky to have a negative NPV.
In your presentation, when you go to your presentation, you can argue it, maybe, that the project has got 60 chances that the NPV will be positive, and the 40 chances that the NPV is going to be negative. So it's going to be now upon the top managers to make a decision. But you can provide that and defend it.
Okay.
No, in exam.
It's an exam now.
No, they require the question was to advise the management or whether to accept the project.
Of course, in exam we are rejecting.
Ah, okay.
Yes. Can you go to decision table or can you leave the POF table? Since you did even in the performance.
ntabwo turayikora bamwe performance tuyikora bwa nyuma tugiye kurangiza.
aho ntiturahagera.
ariko hari abari kuyikora mwikwirebaho mwenyine natwebwe tuyikora.
Courage Olive, uraho.
none se wagira ngo ayireke Olive kubera ko uzayikora ko atubwira ngo arayireka.
Courage Olive.
uragira ngo ayireke.
Olive aragira ngo atishyura ya performance.
If you go for payoff table.
kubera ko tuzayiga muri performance nawe ukaba uvuga ngo urayikora uragira ngo ayireke.
If you go for the payoff table, we have the probability, we have the cash flows, in year 1, probability year 2, cash flows year 2. Then I have joint probability. I have the total cash flow. Then I have my expected value. I think we can look at this. Remember, probability is 0.6. The probability is 0.6, and it can be 0.4. Now, if the probability is 0.6, I didn't put 0.4. If the probability is 0.6, here we had 70 what? 78? 78 what? Members, you are not telling me. What were the cash flows after if the probability is 0.6? What I remember, this one is 45, 450. This one is it?
78,174.
78,174. That's the cash flows. Now, what will be the cash flows in year 2 if this is the probability? I think I can copy these ones. And I can also copy if the probability is here.
No, that one should go to a cash flow. You have put in the column of probability.
I've put in column of probability. Okay, let me copy it again. I can also copy the probability. I think now it's almost, I think this, I don't know which one you're looking at. Now, to get our joint probability, we are going to get this plus this. But this time, sorry, this time is this. So it's going to be 0.6 times this. It can be 0.6 times this. 0.6 times this. Here it's going to be 0.4 times this. 0.4 times this. And this will be 0.4 times this. So that's going to be the joint probability. Now, what will be the total cash flows? In year 1, we are getting it. Sorry, not plus, times, plus this. Okay, what have I added? This plus this. This plus this in year 1. I mean, when the probability is good. This plus this. Probability is bad, it can be this plus this. It can be this plus this. It can be this plus this. Now, your expected values. Your expected values, we are getting the joint probability times the total cash flows. So what do you get? as a total expected value. I think it is similar to what we got in the first year when using a decision tree. This is the total expected PV. And our initial investment IO is 100. So expected NPV is this one. I think we are getting the same answer we got in our decision tree. But have you followed it?
This is the easy way.
This one is the easiest.
Yes.
But others say decision tree is easy. So I don't know if you have a question on this. Members?
It's understandable for me.
Any question? Oh, power has failed to come back. Members have gone away.
The two-way give the same answer.
I think this is what we got in the first when we used the decision tree. This is what we got. And even here, yes.
Why now in this table we add when the conditions are good and when the conditions are bad?
Even the other one we added. We are adding. You check. All these were additions. We added when the condition we are good plus when the condition we are bad. Get this total. See, we are adding.
I think the easiest way is payoff table.
Yeah, but some say decision tree is the simple.
Yeah, decision tree is it takes a long way.
Than this table. So that is a probability. This is a probability, how to use probability to get, to determine the value. Now, we can go to the next part where we have to use the certainty equivalent factor. We are looking at how to incorporate risks in our investment. The first we are looking at is how to use the probabilities to incorporate risks in our investment. So the second part that we are talking about is the certainty equivalent factor. And what's the certainty equivalent factor? The certainty equivalent factor is the level of cash flows that are considered to be risk-free by the management, or the level which is acceptable. The level of cash flows that is going to be acceptable to be risk-free by the management. That's what's called a certainty equivalent factor. Now, if you have if you look at, say, if I'm expecting 100 million with risk, what is the level that is going to be considered to be risk-free of those cash flows? So the CFP or the CEF is the level of cash flows.
Yes.
Which which is considered to be risk-free by the management. So that's what we have as the certainty equivalent factor. The level of cash flows which you think you look at, that this is the level of cash flow that I can accept. If the cash flows go below that, I can't take it. So the more you are going into the future, the more the risk. So the lower the level of the cash flows. So what are the steps in a certainty equivalent factor? Steps in a certainty equivalent factor. Step number 1, adjust the cash flows with certainty equivalent factor to get free cash flows. Adjust your cash flows with the certainty equivalent factor to get the free cash flows, meaning you are going to get your cash flows multiplied by the certainty equivalent factor. Then you get the free cash flows. Step number 2, discount the free cash flows using the risk-free rate. After adjusting your cash flows with the certainty equivalent factor, then discount those cash flows using a risk-free rate. Because you are now having cash flows which are risk-free. So you should discount those cash flows using a risk-free rate. Then the third step is to determine the NPV or determine the NPV of the project. So these are the 3 important steps when it comes to use of a certainty equivalent. And we are saying certainty equivalent factor, it's the level of cash flows which is considered to be risk-free. It means you have already adjusted the cash flows and they don't have any risk. So if you can look at a simple example on this.
Management can only accept investment.
Let's look at this simple example on how to use certainty equivalent factor. So we have company X is evaluating a project that requires 50 million. The project will generate those cash flows in year 1, 2, and 3. The management can only accept investment at the following level of certainty. Year 1, it means the cash flow should be at 85%. Year 2, it should be at 80% in year 2. And the year 3, the level should be at 70%. The risk-free rate is 8%. Required, advise the management on whether to accept the project. So if we look at this, we have our period, the period, we have the cash flows, we have our certainty equivalent factor, then you have the free cash flow, you have a discounting factor, which is now at 8%.
Yes.
Then you have the present value. So we have period 0, period 1, period 2, period 3. Period 1, we need 50 million. Period 1, we have 30, we have 35,
Yes.
25,
25. Yeah, 25, yeah. And
we have
35.
35.
Yes.
Our certainty equivalent factor in period 0, that's where you are. It means period 0, you are certain. Because that's where you are. It will be 1.0. This will be 0.85, 0.8, and this is 0.7. So our free cash flows here will be this times this. And this will be this times this. So now I can discount the discounting factor, which is 1 plus 0.08 power minus this. So our present value, just to get the free cash flows times the discounting factor. So what will be the NPV? This is the NPV. So in that case, you are going to accept the project. I think this is not very complicated, like using probabilities. What you only need is to, this
It's
one is
not
user-friendly. User-friendly.
Yes.
So that is how, what you need to look at is to know the rules. That you first adjust your cash flows with those certain equivalent factor. After adjusting your cash flows, discount the cash flows using risk-free rate. Any question on this?
It's understandable.
So we can now go to sensitivity. Sensitivity analysis. We are looking now at sensitivity analysis. And our sensitivity analysis, you are looking at how each variable will affect your NPV, how sensitive the variable in your NPV calculation. That's the sensitivity analysis. The level at which one variable or the degree at which a variable should change in order to affect your NPV. That is a sensitivity analysis. So you look at variable per variable when you are computing your NPV. So sensitivity, it shows.
When you say variable, you mean factors?
The variable you are using to compute your NPV.
Okay.
Yes. It shows the level or degree by which variable used in NPV computation should change before affecting the NPV. You are looking at how the variable that you were used in the NPV computation, how will they change in order to have an impact on your NPV? By what level or by what degree should those variable changes in order to have an effect on or to change your NPV decision? We know you make an estimate of costs. So because you have estimated your cost, your concern will be, suppose my cost increases. Because you estimated, you expected the cost to change. Suppose the cost increases, how will they affect? By what percentage should these cost increases before affecting my NPV? You also make an estimate of your revenues. By what level should your revenues change in order to have an effect on your NPV calculation or on your NPV decision? So you are going to analyze variable per variable in your NPV. So we can have a simple example on this. Or before look at how do you get the sensitivity? Sensitivity is equal to NPV divided by the present value of the variable. Of course, you multiply by 100. Get your NPV divided by the present value of the variable. For example, if I'm looking at the sensitivity of revenues, it will be the NPV divided by the present value of revenues. If I'm looking at the sensitivity of variable costs, it will be the NPV divided by the present value of the variable costs.
You times by 100, eh?
You multiply by 100 because it will be in a percentage. So we can look at a simple example, maybe for 2 years or 3 years. Company X is evaluating project that requires 60 million. The forecasted demand is as below. This is year 1, year 2, year 3 units. Year 1, maybe 80,000, 100, 150. Selling price is 540 per unit. While the variable cost is 230 per unit. Fixed costs is 2 million for fixed production costs. Is 2 million. Oh yeah. Correct. Carry out the sensitivity analysis on the project. Let's look at this and see how we can be able to use the sensitivity. Of course, we do the same process. You're going to have your revenues. I don't know if you can just calculate the same here. We make a working one. You can have your revenues. Working one. We have the revenues. Year 1, year 2, year 3. My revenues. I'm going to reduce 3 zeros, 80, 100. This is 150. The cost of capital, I've not put the cost of capital. These are units. Price is 530, 540. So my revenues will be this times this. Since I'm going to do sensitivity, what is important here is to get the present value of the revenues. such that I don't need to, my discounting factor for is it? Discounting factor at 12%. So I have 1 plus 0.12 power minus 1. I want to get it such that it doesn't take me time to take this. Because in sensitivity, we need the present value of each variable. So my present value will be of the revenue, this times this. So my total PV, total PV will be, I can add that's the total present value of the revenues, which I will use. Now I need also to get the working number 2, variable costs. I can copy it here, I think. I can copy here. What's the variable cost per unit? Is what? 230. Variable cost per unit is 230. So what is my variable cost? I multiply this times this. So I can copy this discounting factor. I also discount the variable costs. The present value of variable costs times this. So what's the total value of my total PV of variable costs will be, still I'm going to add all the 3 years.
Orne, Tanzania mazi. Oh.
So now I can get my fixed costs. Those ones.
Hello? Do this.
Please mute. Mute your microphone. Not even seeing her.
Yes.
Muhamazi.
Working is 3, we have the variable costs. So year 1, year 2, year 3. So our variable cost, I think, is 2 million per, fixed costs. I can also copy again the discounting factor. Hey. So what is the PV? Times this. So the total will be sum. So now, once I have that, I can now get my NPV because I have now got the present value of each in the computation of carrying out a sensitivity analysis. So what I'm going to do now is get the NPV of the project, NPV at 12%. Already I have, I can start maybe from here, 0, 1, 2, 3. So my investment, my initial investment, I think is 60. I can start with revenue, sorry. Let me start with revenue to be organized. Revenues, not the discounted. I take the revenue which are not discounted. These ones. Then I take the variable costs. Also the undiscounted ones. The discounted are only to help me. Are only to help me to be able to compute my sensitivity. Then the fixed cost. Still I take this fixed cost, the one which are not discounted. So my earning before tax. So we did not consider tax, so I can leave that. So my initial investment is 60, I think. So net cash flows. Don't have residual. Net cash flows. Then my discounting factor at 12%. Plus 0.12 power minus this. So what is the present value? Times this. I think this one is the normal getting the NPV we have been discussing throughout. Where is this minus coming from?
I think there is a problem on net cash year 3.
Yeah?
Even perhaps from the formula.
This
No.
one is coming from where?
The net cash.
But why don't you use the discounted fixed cost?
What is our NPV? We just add the summation. So that is the NPV. Now, once you have the NPV now, you can do the sensitivity. What will be the sensitivity of revenues? That's the first one. Sensitivity of revenues to be NPV divided by the PV of revenues. Then I can get the sensitivity of revenues. It is NPV divided by the present value of revenues. So what do you have is in my data? If you check my data, I've already got the PV of revenue. PV.
Sir, there is a problem in the third year.
There's a problem?
Yes, over there. The net cash is what? Revenues is 81,000.
81,000.
81,000 minus 34,500 equal to 46,500. Minus 2,000. Minus 2,000 equal to 44,500.
Anyway, how come this one is it?
Try it.
It is this?
Yes, minus or plus.
Plus.
Yes.
This. Plus this.
Plus again.
4,500.
Yeah.
Yeah.
That's correct.
Okay. I don't know what was in the Excel.
Yeah.
Okay. So any people have it, it is already there. What is the present value of revenues? We already got it up there. We got what? We don't remember. One 139, 274. Isn't it? 139.
$74.
274. Can you put substitute now in the formula here? It will be 15. 150
over
divided by 139, 274. So what is the sensitivity now?
It's 10.08 what? It's
10?
10.87.
87%. So meaning that if your revenues decreases, that's what it means. If the revenue decreases by 10.87, your NPV will become zero or will affect your decision. If other factors are healthy, because you are looking one variable per variable. If you keep all other factors constant, but the revenues decreases by 10.87, it becomes the NPV becomes zero.
Zero or negative?
No, it does not go, but it becomes zero.
Wow.
I think it is good to write that interpretation.
More clarification on it.
Is it okay?
You can write that interpretation lecture.
Holding other factors constant. A decrease in revenues by 10.87% will make NPV 0. So that is how you're going to interpret. Now, if, for example, you do a sensitivity, I think you can only do one sensitivity. If you do sensitivity of variable costs, sensitivity of variable costs, which will be NPV divided by the PV of variable costs. So our NPV, we know it. NPV
is 15.
Is this.
Mm.
Our PV of variable cost?
59,300. PV of variable cost is 59,320.
59?
320.
320. So meaning, if we look at our sensitivity, it's going to be it will be 15, 150 divided by 59, 320. Eh.
25%, 25.5.
25.5%. What does it mean? It means that if holding other factors constant, if you hold all other factors constant, an increase in a variable cost by 25.5%, if your variable cost increases by 25.5%, your NPV will go to 0.
Excuse me, Rekila.
Yes.
Come back to revenue sensitivity. Is it if the revenue decreased by 10.87% or by more than 10.87%?
No, if it decreases more than 10.87, it becomes negative.
Oh, okay.
But if it is 10.87, it becomes 0. But an increase more than that, NPV becomes negative.
Okay.
Mm-hmm.
That's clear.
Yes. Now it's the same here. If your variable cost, if you keep all other factors constant and increase your variable cost more than 25.5, automatically the NPV will become negative. So if there is maybe an inflation and the variable cost increases by this, more than that, you are going into negative.
Excuse me.
Yes.
On the revenues, the decrease, on the cost, and it is an increase.
It's an increase.
Yes.
Mm-hmm.
So I think you can look at the sensitivity of initial investment, look at the sensitivities of fixed cost. But that's how we do a sensitivity analysis. You look at factor per factor. I don't know if you have a question. So you can do the
Is even a sensitivity for the initial cost?
Yes, because you also estimate the initial cost. You can do
Oh.
the sensitivity for initial investment. By what percentage your initial investment increase?
Excuse me.
Yes.
There's no overall conclusion.
No, because you are looking at each factor, you analyze it separately, independently. So I don't know if you have a question on that sensitivity.
You can as well copy that conclusion for variable cost.
Yes?
I mean, to write that conclusion.
So that is the So now when it comes to simulation is an engineering. We are not going to look at that. It's engineering, but in simulation, you are doing or you combine all the factors.
Excuse
then
me.
you simulate. Yes.
What have you said about the sensitivity of fixed cost?
I have not, because it's almost the same. You are getting the present value of the fixed cost divided by, you have not calculated it, but since you have the data, you can do it. Since you have every the variable, because you have it here. Get this divided by the other, then you see how it can. Then you can also do the sensitivity of the initial investment. Because we have four variables, I think. We have revenues, we have variable cost, we have fixed cost. You can also take the sensitivity of EBT. You can look at it. You have the initial investment. So members, these are the key methods used in risk, when we are incorporating risk in our investment appraisal. So I think
tutari bukore simulation ntago bayibaza in exam.
Yeah, simulation. Simulation, it was to explain what is simulation. It was, I think, you were supposed to differentiate between sensitivity and simulation. There's a question where you were asked to differentiate between simulation and the sensitivity. If you check in the papers, it's there, but it's about explaining about simulation and sensitivity. You cannot do simulation in an exam. But I
Does it
think
involve any calculations?
no, because most of the simulations are done by computer. In finance, we do simulation using computer.
njyewe utamwumva cyangwa namwe mwebwe muramwumva?
ahubwo nanjye nagiye kubaza the same question.
Internet yagiye se?
Twakumvaga.
Ntabwo twakumvaga.
Ntabwo twakumvaga.
Maybe internet yari yagiye. We were talking about, someone were asking about simulation. And I was saying, there is a question, if you check in your past paper, where they asked the difference between simulation and the sensitivity. And I want to say, in sensitivity, you analyze one variable per variable. Look at how that variable can affect your NPV. In simulation, all of variables are combined and analyzed how they can affect your NPV, but using computer software. That's what I can say. You can combine all variables together. Then if all variables are combined together, how will they affect my NPV? But it is done by computer software.
Excuse me, sir.
Yes.
I was wondering if we talk about the impact analysis.
The impact?
Impact analysis.
Of a project?
Yes.
That is cost-benefit analysis. Do we teach it in corporate finance?
You see, like...
Yes, I understand, but we always look at impact analysis of a project when we are doing cost-benefit analysis. I don't know if we look at it in this, but I don't know. Have you seen a question on impact analysis?
Yes, yes.
And they are asking to determine the impact analysis of a project.
I mean, they have given us a rate.
A social rate?
No, they were like, what would be the impact if revenues decreased by a certain %?
That is sensitivity.
Okay.
Yeah, that's the sensitivity. But
okay, continue. That simulation will not be asked. We continue.
No, there is no calculation, but you can explain that about sensitivity. So the last part that I want us to discuss today, I don't know if you can finish it. Capital rationing. It's not very big.
But sir, again, the time.
Yes.
I think we agreed to end at exactly 2 p.m.
No, 8 p.m. or 9 p.m. What's our time?
Maybe Felix.
9. It's 9.
Felix lied to me.
Moje Chupaman.
Yeah, the class ends at 9. I think that's our agreement.
9, it's worth it.
So let's end with this. I think we can finish it in this. Now, it is because in investment, you may have different projects which are profitable. For example, the investment team can bring around 10 projects, and all the 10 projects are profitable. But you find that the budget allocated to those investments is little. In that case, we say we are in a capital rationing. So capital rationing is when the entity is having insufficient funds to finance all its project. That's what we call a capital rationing. It is when the entity is facing a challenge of insufficient funds, finance, or its projects. So the business may be having, as we are saying, the business may be having projects that are profitable, but you find that you don't have enough money to finance all your projects. In that case, we say that you have a capital rationing. Now, capital rationing.
Maybe or profitable project.
Yeah, you have, but the money profitable. So capital rationing is caused by both soft and hard.
Hard what?
Hard factors or hard factors. So sometimes we say, when it comes to capital rationing, there is a soft capital rationing and a hard capital rationing. Now, if you come to soft capital rationing,
those are the type or the cause.
Type. Because these are factors within these causes. I could say the ends are the, but you have to what causes.
We can't hear you.
I think the network is moving away. I don't know. When it comes to capital rationing, it is mainly caused by factors that are hard, or we have a soft capital rationing factor and a hard capital rationing factors, or soft capital rationing and a hard capital rationing. So when it comes to soft capital rationing, a soft capital rationing these are mainly caused by internal factors. That internally you are unable to generate enough money to finance the business. In that case, we call it soft capital rationing. So we can say that this is mainly caused by internal factors such as, and it means this is not very good, like the shareholders are not willing to raise more capital. So you find that the shareholders are not willing to raise more money to finance the project. In that case, it is an internal factor. You have a good project, but the shareholders are not willing to put in more money in the business. Number two, when there is a limit on the amount to spend, you may find that the manager has been given a limit on the amount that the manager can spend. You have a good project, you cannot exceed a certain limit of money spent in a given period. Then another one can be poor budgeting by the management. You find that the management did not take care or did not put into consideration of these capital expenditure. They didn't plan those capital expenditure. So in that case, you are going to have these are factors that may cause soft capital rationing. Now, if you go to the hard capital,
limit on the amount to spend.
if you go to the hard capital rationing, still you have insufficient funds, but the insufficient funds are caused by factors that are external to the entity. The entity is having this challenge of insufficient funds, mainly caused by external factors. So the entity is facing a challenge of insufficient funds, mainly caused by external factors, such as low price of shares in the market. You find that the price of a share is very low in the market, so it becomes hard for the company to raise the money, the money or the capital it wants, because the shares in the market is very low. Number two, limit on the amount to borrow. Limit on the amount to borrow. You know, companies, they have that in their memorandum or articles of association, that there is a limit on which on the amount that the management or the company can borrow. So you have a good project, you have a limit on the amount that you can borrow. So that one can also be an external, can have also government policy. The government policy. So you may find that the government has limit, maybe on the banks, on how much they can lend. That the banks are not maybe lend. Maybe they have a high for the banks. If the government put a high reserve ratio for the banks, then it becomes hard for those banks to lend. So those can cause a hard capital rationing. Now, the key area now, or the key question is, if we are facing these challenges, how can we make an investment decision when we are having this capital rationing? So how do we make an investment decision in a capital rationing? So that is investment decision and capital rationing. Investment decision and capital rationing. How do we make an investment decision and capital rationing? Now, when we are to make an investment, the investment decision is divided into. We have divisible, or we divide our projects into two. We have projects that are divisible and the projects that are not divisible. So if the projects are divisible, it means you can be able to implement those projects in phases. Example, if you are building a school, you can start maybe with the nursery. From nursery, you go to P1, from P1 you go to P2, you go on implementing slowly. In that case, that project can be divisible. But if you cannot, if there are some projects which are not divisible, meaning you either implement or not.
Sir, the sound is tired. Eh?
Sound is it?
Tired. You
No,
are cutting
maybe
off.
it's network, not my sound. My sound.
No, not your sound. The sound in general.
I always invest. So that's the business. I have to invest money in the sound.
Not your voice, eh? Not your voice.
The network. So what can we do? There is one small part. Maybe, I don't know. Like that when we meet again.
No, we push until we finish.
You have this, finish this. The remaining D. I wanted this week to finish this part of investment. When we meet again, I see we start mergers. I don't know if it will be possible. So we are saying the investments are divided into two. Number one, we have what is called the divisible projects.
Okay.
Divisible projects. And number two, projects that are not divisible or indivisible. Projects which are not divisible. So when you are making a decision under capital rationing, you're going to look at the type of the project. Is the project divisible or the project is not divisible? Now, what are divisible projects? Divisible projects. So when we say divisible projects, we say these are projects. These are projects which are implemented in phases. So you can start a project, implement partly, then next year you continue with the same project. In that case, you are having divisible projects. So if the projects are divisible, if the projects are divisible, the decision should be made using the profitability index. Now, if you have divisible projects, you are going to make the decision using the profitability index. So what you are going to do, you rank maybe the steps. Rank at the project or compute the profitability index. Compute the PI of each project. That's the first step. Compute the PI of each project. Then, step number 2, rank the projects according to the PI. Step, you're going to define each project. I think you know how to compute the PI from our previous list. Step number 2, rank the projects according to the PI. So meaning the project with the highest PI should be ranked first. When you are ranking, the projects with highest PI should be ranked first. Then, step number 3, allocate resources in the order of the PI. From the highest to the lowest. I hope you are now. We are saying if the projects are divisible, you will make a decision based on the profitability index. And what are the key steps in this? Step number 1, you are going to compute the. Please mute. Please mute. Compute the PI of each project, rank the project according to the PI, then allocate resources in the order of the PI, from highest to the lowest. That is when you have divisible projects. Now, if the projects are not divisible, our last part, maybe when we meet again, we shall look at a simple example. If the projects are not divisible, projects are not divisible. It means you cannot implement the project in phases. So if the projects are not divisible, the decision is made basing on the NPV. A combination Now, if you have projects that are not divisible, what you do, you are going to make your decision based on the NPV. You are going to compute the NPV of each project, then determine a combination which gives the highest NPV. That's the one that you are going to select. So the steps here, step number 1, we finish. Compute the NPV for each project. Then step number 2, select a combination Please mute that gives the highest NPV and exhaust the resources as much as possible. Hope you are there. When the projects are not divisible, step number 1, you are going to compute the NPV of the project. Step number 2, you are going to select a combination. You are going to look at a combination that is going to give you the high NPV and which does exhaust the resources as much as. That's the one that you should select if the projects are not divisible. So I think, I don't know if you have a question for this class. Any question, comrades, for this class?
Yes, and the question that I have is when we have a multi-period capital rationing.
When you have multi-periods, in that case, you are going to do a linear programming.
Is that examinable in CPA, Rwanda?
Because even in linear programming, you cannot run it without a computer. But maybe you should just know how to explain it. If you have a multi-period, it requires a linear programming. So I think we can stop here. I'm going to share the notes. I think the PDF. Then I will share the Excel, I think, after. So I think we stop here and have a good night. If you don't have a question.
Trial. We meet Wednesday.
Eh?
When do we meet again?
Our next class is Wednesday.
Okay.
Okay.